So tonight we're going to talk about storm sewer. We've already talked about storm sewer. We're going to just drill into a certain component of it. And then we'll see what questions you have and kind of go from there. So let's start with the storm sewer. So in our first submittal, you all got to analyze / design storm sewer. So I'm not going to go over that, but let's just talk briefly overview about what you're going to do, and then we'll get into really what I want to talk about tonight is how do you space your inlets? What's the process in which you space your inlets and where you look at? So most of you have a site layout that looks something like this. You have a road with a cul-de-sac that goes to the pond. Okay. So the idea here is you're going to locate your inlets, collect all this flow, and discharge it into your pond. Now StormCAD limits you to 5 inlets, right? So or 5 structures, I should say. So if you find out that you need more than 5 inlets, you're going to have to probably combine some in order to do that. Okay, so nothing really new there. Okay, but let's talk about inlet spacing. So we did briefly discuss this with the first submittal, but generally speaking, you want to space your inlets. In our subdivision case, most of this won't apply, but if you were at an intersection, you would want to make sure your inlets are spaced so they capture the water before it flows across the intersection. That's probably one of the more critical locations. The other one would be at a low point. So if you had a low point, you definitely want to place inlets. But the other major thing that you have to look at when spacing inlet is what we call spread. And that is how much water do I want to allow on a particular road, okay? So we're going to get into that tonight. But just looking at our typical section, so the typical section's crowned, it's got a gutter, so water is going to end up being conveyed, if you will, along the gutter to an inlet. So that's what we're going to look at. So let's first talk about inlet efficiencies. So every inlet has a certain ability to capture flow. So what we want to be able to do is figure out how much of that flow is going to capture, because if an inlet doesn't capture, what happens to that flow? Where's it go?
It's going to flow down the street.
Well, it's going to bypass the inlet. It's going to keep going. It's going to go to the next inlet. So if you don't capture enough of that water, you may exacerbate the problem to the inlet that's downstream. Okay, so being able to capture that water is pretty important. So in the FDOT Drainage Design Guide, there is an appendix in there that has inlet efficiencies. So for the variety of inlets that you would potentially use, there is a way to look at efficiency. So for this assignment, what I want you to do is assume you're using an FDOT type 1 inlet, okay? So everybody's on the same page. And the cross slope of your road is 2%. So what we're gonna do is if we look at this particular set of curves, okay? What you wanna do is you want to space your inlets so you capture 100% of the flow that approaches the inlet, okay? So how do we do that? So if I look at these set of curves here, depending on your longitudinal slope of the road, it's going to dictate how efficient your inlet is. So the steeper the road, the less efficient your inlet is, right? Does that make sense? Because you have a higher velocity, water is going to tend to bypass that inlet. So the flatter the slope, the more efficient the inlet is. So if you look at these curves, if I had a 2% longitudinal slope, I get about 100% capture at about 2.8 cubic feet per second. Does that make sense? Whereas if I had let's say a 5 or 6% slope, I would have 100% capture at say 1.3 cubic feet per second. So pretty significant difference. So what you want to be able to do is using this curve, depending on your longitudinal slope, is figure out at what point you have 100% capture. Does that make sense? Questions on that? Okay. So keeping that in mind, right? So you're gonna have a maximum flow that gives you 100% efficiency, right? So just keep that in mind. So what we wanna do next is figure out what is the maximum amount of water we want on our road. What is that maximum spread, okay? So for a local road in Orange County, we can technically flood the entire road. So the lane width plus the gutter width would be our maximum spread. So we're just gonna call that T-max. So what's a lane width?
12 feet.
12 feet, right? So if I say 12 feet plus, what's the gutter width?
4.5. 4.5.
Foot and a half, right? So that means I have 13.5 feet. That's the maximum spread I can have on a residential road. So what I want to do is I want to solve this equation. And what I want to do is I want to solve for Q. But let's just make sure we understand these variables. So N is roughness coefficient. And that's the roughness coefficient of the asphalt and the concrete. So that's a pretty standard value. That's 0.016. Okay? Cross slope is S of X. What's that?
2%.
2%, right? So we're going to say that's 0.02. Longitudinal slope is going to be the slope along the roadway. So that's going to be something that you'll have to determine what that is. Okay? And then T, we're going to make this T max. So T max is 13.5 feet. Everybody see that? So what I'm going to do is I want to solve this for Q max. So if I know the cross slope, longitudinal slope, I know the maximum spread, I know the roughness coefficient, I can solve for Q max, right? So this is just a form of Manning's equation. So once I know that maximum flow, how would I determine my inlet spacing? Anybody have an idea? What if I said I can use the rational method? So Q equals CIA. So if I say this Q is Q max, and I say that A is A max, that's the maximum drainage area that I can have drain to the road that yields a 13.5 foot spread. Okay? So if I know my Q max, I know my rational coefficient, I know the intensity, I can calculate that maximum area. So let's walk through how you do that. First, intensity, we're going to use 4 inches per hour. This is a standard FDOT rainfall intensity when you calculate spread. So you got that. Roughness or rational coefficient is really just the rational coefficient of your subdivision. So it would be the road plus the lots. So you essentially determine that with your second submittal, right? You did some things, so you should know that value. So what is A max? How do I can calculate it, but what does it represent? Again, it represents the maximum drainage area that's going to yield that spread. So really all that means is if I look at my road, and say this is Gemini, and I think about the fact that I have lots on both sides, and all these lots are draining towards the road, okay? Then that area max would essentially be, that drainage area. So I know the width of the road, and I know my lot depth, right? I know how deep the lot is. if I'm assuming the lot drains to the road, I know that half the road is 25 feet, and the lot depth, what's the lot depth somebody had, roughly?
184.5.
Exactly 184.5?
Yeah.
Okay, 184.5. Okay, so that's my width. So this is my length. So area max is length times width. I know the width, so I can calculate the length. So that length is the length along the road that yields this 13.5-foot spread. So for that length, that determines what my inlet spacing would be based on spread. Does that make sense? Questions on that? Yeah.
That's the length between each inlet from one inlet to the other?
Say that louder.
So that's the length from one inlet to the other?
Correct.
Okay.
Yep. So that's, and it's on a continuous slope, okay? So that would be, that length would be the spacing between those inlets.
For the road, you have 25. Is it 25 for the full road, or is it 12 and a half, or 12 for the?
12,
Half.
well, your right of way is 50 foot. So half of the
Wait,
right of way
what's
is
the-
25,
Okay.
so therefore half of the road drains to one side, right? So again, the assumption is these two sides kind of are mirror images of each other. We're kind of simplifying it to a certain extent, but that will yield you that length. Okay, so we talked about spread. Let's go back to inlet efficiency. So the other part of this is, if this Q is less than this Q, right? So if my inlet efficiency Q, let's just make up a number. Let's say that's 2.5 feet per second, or 2.5 cubic feet per second. And let's say this Q max is 4.7 cubic feet per second. Which one of these is going to govern my inlet spacing? This is, right? So if I have that case, then the inlet efficiency is going to force my spacing to be tighter, right? So what you'll need to do is, I'd like for you to calculate your inlet spacing using this equation, right? Figure out what that is, and then determine what that is, and then you can come to a conclusion about what your inlet spacing is. So if I have this flow, I can calculate the spacing the same way, right? It's just, it's a different flow, so I can get that length. Does that make sense? So again, for your assignment, the storm sewer part, the goal is, how many inlets do I need and what's the spacing? So I'm gonna look at my inlet efficiency. We're using type 1 FDOT inlet, cross slope of 2%. I'm gonna calculate that. I'm gonna calculate my spacing using this equation. And then at the end, I'll determine which flow governs, and then calculate my spacing. Make sense? I think that's the hardest part. Once you know where the inlet spacing, you can lay it out and then run your storm cap. Anybody? Yes?
I get the left side, the right side, when you're explaining into the area max, that 25 foot, I know that's the right of way. Isn't the 13.5 just referring from curb to the ground at that point? So is the 25 not including the 13.5?
Well, understand too,
We've got sidewalk.
so you've got a you've got a sidewalk out there, so from this point to the right of way is 25 feet.
Mhm.
Within that 25 feet, I have a 12-foot lane, I have a curb and gutter, I have a sidewalk, and then I have a grass or landscape area. Does that answer your question?
So is the L being, are we determining the L based off of the Q we get from our inlet? Or are we?
Let's let's walk through it one more time, okay? All right. So you have two ways that you're gonna look at essentially determining your inlet space. The left side of the board, you said you understood. Okay. So the right side of the board, we're gonna use a form of Manning's equation that will give us the maximum flow. Okay, that maximum flow is based on a spread of 13.5 feet. The road right-of-way total is 50 feet wide, half of that's 25 feet. Within that 25 feet, I have a 12-foot lane, I have a curb and gutter, a 5-foot sidewalk, and then I have some grass or landscape here. So that total is 25 feet. But that spread really only applies to the lane and the curb and gutter. So that's how you get to 13.5 feet. Follow me so far? Yes? Good? Okay. So, once I know that, I can calculate this Qmax. Because really all I'm doing is just plugging in numbers here. Tmax, cross slope, longitudinal slope, Manning's roughness coefficient, right? So I can get this. And then this, I can calculate an area using the rational method. Right? Was that the missing link? Okay. So if I use the rational method, just solve for A max. I can calculate there, and then it's just blank times. Okay? Yeah?
Where did W come from again in the AMAX equation?
The width is essentially the depth of your lot and half of your right of way. That way. Yeah.
The longitudinal slope, how would you calculate that?
Anybody have an idea? How would you get my longitudinal slope? Yeah.
By looking at the contours?
Yeah. I would look at the contours. Just follow it along your roadway.
I think my problem is that I will calculate that if I know already where the inlet is. So I will calculate the difference in elevation from one inlet to the other, and then calculate the slope from that.
You could. What I would do is I would just holistically look at your road from start to end and just estimate an average slope. That's what I would do, and I think that's fine. I'm not worried about the nuance of the road. Okay. Anybody else on that? Yeah.
So once we find the drainage area for one inlet, where do we know to kind of locate or draw in within that boundary where the inlet would be?
So the idea would be that once you know your inlet spacing or your maximum drainage
Right.
area, you would space all your inlets to be within that realm, if you will. So let's say that I whichever one governs, the length was 200 feet. So essentially I would go along my road, starting at the top of Gemini, and just space my inlets every
Got it.
200
Okay.
feet. Now, I mean, it's gonna end up being, you calculate 200 feet, but to make it fit, maybe it needs to be 180 feet. It just depends on how you orient your inlets.
Right.
Okay, but that's the idea.
Okay, only use type 1 inlet.
Yes.
And we're also assuming that everything is on sag for the inlets?
You're assuming it's all in a continuous grade.
Yeah, okay.
It's on a continuous grade.
Oh, okay, yeah.
Yep. Anybody else? Okay. So let's just make sure everybody knows what you're doing for submittal 3. Okay? So submittal 3 kind of runs the gamut of a few things, right? So the primary focus is utilities. So your water, sanitary, and storm. So those 3 utilities that you're designing. Okay? Talked about how to design your sanitary. Right? Use Flowmaster, have a table. Right? So your potable water, you use WaterCAD. Calculate your demands, verify your pipe size. And then the storm sewer, talked about tonight. Does anybody have any questions on any of those pieces? Okay. The other part, which is somewhat related, is you're gonna write a simple proposed scope. you're gonna pick one of your projects from assignments 1 through 2. Right, scope. So you have a scope, you're gonna estimate what your cost would be as a consulting firm, and then put together a single schedule. Okay? So that's assignment 3. Anybody, any questions on any of that? Yeah?
So assignment 3 is a paper submittal, or is that the PowerPoint presentation?
It's a paper submittal.
Okay.
So then next week, everyone will do a brief presentation, every group, okay? And the presentation is really focused on your proposal, okay? What you're proposing, what the costs are, what your schedule is, and then, you know, introduce the project, you know, that kind of thing. 5 to 10 minutes. We have 10 groups to go, so obviously it's gonna be an exciting time for everyone. But my hope is that not everybody picks the same project, because if everybody picks the same project, it will be even more fun. Hopefully there's a little bit of right, but that's the idea. So let's just focus on that for the oral presentation. And go through it. You know, yeah, use PowerPoint. Make sense? Any questions on the presentation? So, yeah,
There's no cost estimate included.
I don't believe I added that to your outline, but yes, you should do a cost estimate for the pipe systems. And I will make sure that I include unit costs for the things that aren't in the DOT. I'll do that, tomorrow, get that over with. Okay? So I realize at the end of the semester, everybody's got a lot of crap going on, but hopefully you're not too far behind. Try to keep it somewhat simple, okay? So, it's a short class, that's all I have tonight. Do we have anybody presenting tonight? Or did we finish? I was just trying to remember, somebody asked to move it.